Hi, I'm Jack. I'm a sound designer with a decade of experience as a vehicle technician. In this video, I'll be walking you through how I've created my surface detection system in Unreal Engine 5 and Wwise. The goal for this system was for all four vehicle tyres to detect and play the four surfaces that occur in the game dynamically, whilst using spatialised emitters for better player immersion. I also wanted to control the intensity of the surface audio depending on the vehicle's speed. Originally, my implementation relied on wire switches. However, due to the time delay between multiple detection points and the way switches operate in Wwise, this produced phasing. This is because wire switch changes initiate a restart of the object's audio loop, regardless if you set up for step or continuous play modes. Say for example you're driving on asphalt at 30 miles per hour and you veer off track to the right. The first wheel to change surface will be the front right followed by the rear right, and then the front left followed by the rear left. As you can imagine, this creates three different varying delays, and with the nature of racing games changing surface at speed, this starts to get very messy very quickly. Using seek event actions to start playback at random positions helped with phasing, but also introduced clicks due to starting playback from non-zero crossing points. My solution to overcome both the phasing and the clicks was to implement a surface volume RTPC system. This starts all surfaces on begin play and quickly drops the volume of all inactive surfaces per object, leaving only the active surface audible. This means that all surface loops are phase locked from the start, and we are essentially operating a little volume mixer for each wheel. Here's how the logic works in blueprints. First of all, we post a tyre surface audio event on begin play to start all surface loops playing from their respective emitters next to the vehicle wheels. And then on tick, we run the update tyre surface function. This logic references the socket location in the skeleton asset to fire a line trace. This detects the physical material the line trace breaks on and compares the new surface to the last surface detected. If a change is detected, we switch over to the new surface by setting the respective surface RTPC to 1 and all others to 0. We then finish the chain by updating the last surface variable to repeat the cycle. This code is then repeated for the other three emitters and sockets. In the viewport, we can see a visual representation of the AK component emitters and the attenuation spheres with the attached events. I've also temporarily attached a cube for visual representation in-game. In Wwise, each surface blend track has 3D spatialization enabled and is using an attenuation ShareSet. Unreal Engine uses 1 cm as a game unit, so max distance needs to be multiplied by 100 to convert to meters. In this attenuation ShareSet, we are using a volume curve to adjust the volume based on distance from the emitter to the listener, which is the camera. Cone attenuation is disabled, as we want to be able to hear the emitter at equal volume regardless of the camera placement. Each surface type uses a blend container with different intensity loops that layer on top of each other using volume and filtering curves as the vehicle speed increases. The rumble strips are a little more complex, and I'm making use of two transient focused static loops that are time stretched to simulate the sound of the tyres driving over the rumble strip grooves at low speed. I've used the time stretching effect here rather than basic pitch, so I can speed up the playback rate whilst keeping the pitch and tone consistent. Here's how the surface system sounds in game. So that covers a bit of audio theory, problem solving, blueprint logic, implementation, and a bit of creative time stretching. Please check out other videos where I'll go through further systems in more detail. Thanks for watching, and feel free to reach out using the links in the description.